Hey everybody, the purpose of today's video is to be able to solve absolute value equations. These are one of the equations we come across in algebra. The main thing to remember with absolute value is that absolute value is the distance from zero. And although we can go like in a positive direction or a negative direction, once we kind of look at our distance from that, distance cannot be negative. So anytime you have an absolute value equation, you want to make sure that it's equal to some sort of positive value. And we're going to kind of explore some of these types of questions that you may see and evolve them. The most basic form is something like this, where you have x, the absolute value of x is 7. And a lot of times, x can be two possibilities. It can be the positive answer or the negative answer. So for this one, I would break this apart into x is equal to 7, but the absolute value of negative 7 also works. So those are two different options for your solutions. Sometimes in math, your solutions, especially with absolute value, you can leave it as this. Some people like to use braces and just say it's the set of values from 7 and negative 7. You can do that as well. But normally, that's totally fine. The main thing with absolute value equations is that you want to make sure the absolute value itself, whatever's inside of it, is isolated. There's nothing outside of the absolute value symbols, okay? So in this problem, it says the absolute value of 2x minus 13 is equal to 7. You'll notice that there's nothing on the outside of our absolute value symbols. It's kind of isolated. So what we do first is we set this equal to the positive of 7 as well as equal to the opposite, which would be negative 7. Every time we do these absolute values, you want to make sure that it's equal to either the positive solution or negative solution. And we'll look at like a little what happens if there's a little bit of a situation, which we'll see later in the video. And all we do is we simultaneously solve these. So you add 13 to both sides, you get 2x is equal to 20, then divide by 2, and x is 10. Over here, I'm going to add by 13 on both sides as well. You get 2x is equal to, just be careful, 2x is equal to 6, divide by 2, you get x is equal to 3. And our two solutions are, in fact, 10 and 3. If I was to substitute 10 into x, I get 20 minus 13, which is positive 7. Absolute value of positive 7 is 7. And then if I plug in 3, 2 times 3 is 6, and 6 minus 13 is negative 7, but the absolute value of negative 7 is, in fact, 7. So let's look at a couple more of some ones that are a little bit maybe trickier. So for this one, let's do 4 plus 7, absolute value of 10x minus 9, absolute value symbol equals 11. And this is kind of a good one to look at. So if you notice our absolute value symbol, there's a couple things happening, okay? For our absolute value, the very first thing that's happening to absolute value, the quantity inside, is that it's being multiplied by 7. Anytime you have a number outside of a grouping symbol and there's nothing to show there, it is multiplication. The only problem is we can't distribute over our absolute value. You can distribute over parentheses, but not with absolute value. It almost like acts as a wall. The second thing that's happening is we are having this added by 4, all right, or positive 4. So the very first thing we need to do is kind of work backwards in our solving procedure, and we're going to start by subtracting by 4 on both sides. So we end up with 7, absolute value of 10x minus 9, is equal to 7. Now, since we can't distribute, we can rearrange it, and to do that, we're actually going to divide, or the opposite operation of multiplying by 7, we're going to divide by 7 on both sides. This will absolutely free up our absolute value symbol and whatever quantity is inside of that. Once our left side only has the absolute value, or the expression inside the absolute value, and on the other side of the equal sign, this is also singular. Now we can actually do the solving. If that's positive, we are going to break it up into the positive solution as well as the negative. And sometimes I tell kids to think of it like you're trying to get to the positive direction and negative direction of that distance. So it might be helpful. And then you solve these simultaneously, or one at a time. Add by 9 on both sides, you get 10x equals 10. So x is 1 over here. And on this side, don't forget, you have that negative 1. You're going to add by 9 on both sides. You get 10x equals positive 8. And for this one, you're going to end up with 8 over 10, which we can simplify. Always remember to simplify to 4/5. So that's our solution. You can always plug those values back in and in fact check your work. All right. So the last one I want to look at is kind of like a special case. There's kind of two with absolute value, but this one sometimes throws kids for a little bit of a loop. So let's write this one out. All right. Again, there's things happening on the outside of our absolute value. We have a multiplication by 3 and a subtraction by 5. You are going to start this process by doing the second thing that's happening to this. So the first thing is multiplying by 3. The second thing is subtracting by 5. So we're going to add by 5 on both sides. When you do that, you end up with 3, absolute value of 2x minus 4 equals negative 15. To get rid of that multiply by 3, we're going to divide by 3 on both sides. You end up with 2x minus 4 in the absolute value equal to negative 5. At this step, you have to question yourself and ask yourself, is the absolute value of anything specific, will I ever have a negative solution? The answer is no. So anytime you have an absolute value that's isolated, if you look to the other side of the equal sign, you notice that there's a negative. It's impossible. This is called a no solution. All right, and in many cases, you can say that this is not a true statement, because it isn't. All right. The very last thing that we do come across sometimes, I'll put it over here, is maybe you have like an absolute value of, let's say, 5x plus 2, and it's equal to 0. Anytime an absolute value equation is equal to 0, or an expression is equal to 0, the solution is going to be one answer. So with absolute value equations, unlike multi-step equations, is you have a 2 solution answer, a 1 solution answer, which is going to be this one, or no solution. So for here, we don't have a positive or negative 0. It's just going to be 5x plus 2 is equal to 0. And then you can solve it. So the only value that will work is your negative 2/5. Because again, you want to get that as a negative 2 plus 2, which cancels itself out. So just something to think about as you're working through these absolute value equations. Be careful. Make sure if you notice this or if you notice that things might be a little bit different. Good luck and keep going.